So we did permutations, which isn't this. And today we're going to do combinations, which is this. Okay, so this is going to come up in a second. So now, yesterday we did a little thing where we talked about how many ways can people be chosen in a certain order. So for example, we had that question where we said, okay, let's have 8 people, and we're going to have them race, and which way can they get the gold, silver, and bronze. Now, gold, silver, and bronze are very different metals. So you could say, well, there's a couple ways to do that counting principle. There's 8 for gold, 7 for silver, and 6 for bronze. 8 times 7 times 6. Or we had this, which is 8 factorial over 8 subtract 3, 5 factorial, and you figure out that that is the same as that. Okay, that's what we call a permutation. This question here is a little different, and I think the example that your text or your course uses is actually a pretty good one. If we have 6 people and we are going to take them and say, let's choose a president and a vice president between those of those 6 people, you could look at that, and that order does matter, right? You have a president and a vice president; they're not the same thing. Okay, so you have 6 options for this and 5 options for that. So 6 times 5 is 30. Another way to look at it is to say there are 6 people. I want to choose 2 of them in a certain order. That's 6 factorial over 4 factorial, which is 6 times 5 times 4 all the way down, 4 times 3 all the way down, and it turns out to be 30 also. Okay, so if you work this out, it's 30. And that is a permutation. Now, the next question is, okay, forget that. Let's have 6 people, and I want to choose 2 of them. Okay, so the example they use, they're talking about, there was another example later talking about people in a play. So let's stick with this, and let's just see exactly what they say here. If your school decided that co-presidents are in charge, so there's no difference between one president and the other president. They're called co-presidents. How does that differ? Well, the question is different in essence because you're saying, okay, I want to choose 2 people. Okay, so let's say I choose Bill as my president and Mary as my vice president. Well, that is now the same as choosing Mary and Bill. Okay, I just want 2 of them. So the question is slightly different, and this is what we call a combination. Order doesn't matter in a combination. So the big question you can ask yourself as we go through this, does order matter? Yes, permutation. Does order not matter? It doesn't matter. Then it's a combination. A combination, instead of a C, looks like, or sorry, instead of a P, is denoted with a C. So this question here would have been 6P2. This is now 6C2. Okay, that's one way to look at it. Another way, we write it like this, 6,2 like that. Okay, so that is this and an R. So I'm choosing 2 from 6. Order not mattering. So the formula here is a little different. So let's do the formula first and then see how this makes sense. So I have 6 factorial on top, n minus r, so that was 6 subtract 2, which is 4 factorial. That's the same as before, right? That's this one. And now I'm also going to divide by 2 factorial. And what happens here, this 2 factorial here takes care of the different combinations, bm and mb here, or whatever combination you have here, okay? So this gets rid of the fact that order doesn't matter anymore. We divide by this number here, which kind of takes the things that we have and unorders them, okay? And when you do this, that's 6 factorial. You can just use your calculator. But if you look at that, that's 6 times 4 times 3 times 2 times 1. And again, what you can do, that's 3 times 2 times 1. And then this one is just 2 times 1, 2 times 1. What you can do is that 432, that's this. Okay, it cancels out. And then you go 6 times 5 divided by 2 times 1. And you could actually reduce this. That reduces with that, and you end up with 15. Okay, so kind of a neat difference. Okay, so obviously, let's go back now. Let me just do one more example here. Let's say I have 8 runners, and I want to know who wins a medal. Okay, I'm not saying who's first, who's second, who's third. Everyone is a winner if you get a medal. So that's not a permutation question. That's a combination question. So how many ways can I choose 3 people from 8? Okay, that's going to be 8 factorial divided by 5 factorial, because 8 subtract 3, 3 factorial. So just be careful, 5 and 3 add up to 8. Okay, that works out that way. And when you open this up, that's going to be 8 times 7 times 6. The 5 is going to get rid of everything else, so this will just be 8 times 7 times 6. This is 3 times 2, which is 6. Okay, so that'll cancel that out, and you end up with 56. Okay, so what you're doing here is you're choosing your 3 people, but you don't care what order they're in. And mathematically, what's happening is this here, this little bit here. So if I look at the question from before, if the order did matter, okay, gold, silver, bronze mattered, I have this question, okay. But then I say, okay, I've come up with all these different combinations. I have, let's say I have runners A, B, and C. A wins the gold, B wins the silver, C wins the bronze. Well, how many different combinations are there that now don't matter, right? Because I don't care if it's ABC or ACB or all the way through. Well, let's line these guys up. There's 3 factorial ways to line up ABC, so I'm going to divide by 3 factorial, and that's what I'm doing here. Okay, so you undo the ordering, essentially. Okay, so that's a combination, and there's some really neat questions in your text or your course here. So order does not matter with the combination. Okay, get used to putting this in your calculator. So that here we talk about order mattering and Lotto 649. Lotto 649, Lotto 649, I believe there's 49 numbers and you choose 6 from them. Okay, now the order doesn't matter. So if you actually want to know what your odds of winning Lotto 649 are, that's this question here. There are 49 numbers and 6 of them are drawn at random. Okay, but the order doesn't matter. So if the balls come out 32, 3, and 6, that's the same as them coming out 3, 32, and 6. Okay, so I'm choosing 6 from 49. Order doesn't matter. That's 49 factorial over 43 factorial divided by also times 6 factorial. Okay, so that's here. Okay, so 43 and 6 is 49, so I know I'm right here. This cancels out most of this. I'm left with 49 times 48 times 47 times 46 times 45 times 44. And then on the bottom, I have 6, 5, 4, 3, 2. Okay, multiply those out, throw in a calculator, or you can look to reduce, for example. Here you have 5. That will go 9 times. You can keep going with this. This is a bit of a waste of time here. But that goes to 24, and then I can divide by 4 and end up with 6. 3 goes into what? 3 goes into any of these here? 3 goes into 9 here. So that's a 3. And 6 goes into, I don't know if 6 goes into any of these. Does it? Oh, yeah, 6 goes into 6 ones. Okay. So I have 49 times 47 times 46 times 3 times 44. That's just a reduced form. You don't need to do that. You can just throw this in your calculator like this. Some calculators will actually handle this as one step. And you notice, if you go back to the answer, if you have one ticket, the only way you're going to win is if you get the right numbers. And there are a total, I believe, of, yeah, it's almost 14 million different combinations. So if you want to win the Lotto 649, you just have to come up with 14 million different tickets and spend 14 million. I think it's times 2 actually, so $28 million. So you think about how much money the lottery companies make. If they're scooping in all this money, and the odds of that, the odds of winning are 1 in 14 million, and the paybacks are less than that, they obviously make a lot of money off this. It's a little bit more complex than that, but that's essentially it. Okay. Any other good questions here? I mean, they're all pretty much the same. Just give them a shot. Okay, permutations yesterday, combinations today. Order matters. Order doesn't matter today. Okay, good luck. Send me an email if you're confused.